Let's do this exercise 1.1.2. So the statement is that the first define what is called morphism of chain complexes, which by definition you have a chain complex C dot and the chain complex D dot, and the morphism is in each degree n. There is a map from Cn to Dn, and this gives you a diagram. We require this diagram to be a commutative diagram. This is called a morphism between chain complexes. The exercise 1.1.2 requires that there is a induced functor from the nth homology module of C to nth homology module of D, and this gives actually a functor Hn from the chain complex to chain complex. So let's look at this. The diagram tells us, firstly, there is natural map from kernel Dn. Let me give it notation Dnc, which means the Dn of C. To Dn of D. Map is given by U, because if you have an element is in the kernel of D and C, then this is mapped to U of X. Obviously this is in the kernel of D and D, because by commutative diagram under D and C this is mapped to 0, and so commutative diagram tells you that under D and D Ux is mapped to 0. Okay, so now you have this map from a kernel D and C to kernel D and D. But the quotient by kernel image, by the image Dn plus 1D is the definition of homology of homology group. Right, this is the Hn of D. And so you have a map factors. You have this map from kernel to nth homology group of D, but the question is, do we have a map from nth homology of C to there? And the answer is yes. You just have to check this image of Dn plus 1C, its image under this composition. I still call it U, or call it U bar if you want. Under U bar is mapped to the kernel, is mapped to 0, in other words. Okay, so the question is image Dn plus 1C containing image Dn plus 1D? This is again the case, again by the commutative diagram, because start with any element Cn plus 1. This is mapped to Dn plus 1. For any element in Cn plus 1, this is mapped to Dn plus 1y, and so this is U of y, and by the commutative diagram this is again mapped to Dn plus 1 U of y, but this is also the same as u of dn plus 1y. And so this implies this image of dn plus 1c under the map u map into the image of dn plus 1d, because, for example, the image of this one is dn plus 1 of some element. And so we construct a map from H and C to H and D. This construct this map, and we have to check this is a functor. It's just a routine to check this is a functor. For example, you have to check the composition. Satisfies f of u composed with v let's call this hn of u, call this hn of v. I have to check the h. We compose u equals h n of we compose with h n of u. This is basically saying that you have an x mapped to v, compose u of x bar is the same as you first map to ux bar and then map to v of ux bar. Okay. And then identity implies identity. Okay.